Good morning, friends. Up to this, we discuss about the MCQ question asked in Neet and also All India PMP exam. The most of the question asked in Neet we covered. Now, today we are going to discuss about the MCQ question asked in Good Set and also the board exam. For that purpose, in Good Set, the Good Set is started from the 2006. Therefore, the two exams is taken in 2006. One is in January, that is the mock test in 2006 for the practice of the 12th standard student. And then the final exam is taken in May. Okay, now the first question is in 2006 mock test. What changes during the polarization of light? Which physical quantities change? Either the frequency, wavelength, phase of a wave, or the intensity. In polarization, what's happened? The intensity is directly proportional to the square of amplitude. Due to the polarization, the amplitude of the light is decreases, therefore the intensity decreases. While the frequency, wavelength, and phase not depends on amplitude. And due to that result, here the intensity physical quantity is changed during the polarization. Because the polarization is only for the longitudinal wave. Longitudinal wave, that means this type of the wave. That is the amplitude. That is the amplitude. So the intensity directly proportional to the amplitude square. Therefore, intensity is only changed. Intensity is changed. While the other physical quantities does not change, like as the frequency, wavelength, and phase. Due to the polarization, what's happened? What are the waves oscillate parallel to the axis of the polarizer? Only can pass a block in this polarizer. Therefore, the amplitude of the unpolarized wave is decreases, and hence the intensity is also decreased. And also in Malus law, we also know that the intensity I is equal to I0 cos square theta, right? Therefore, the the intensity depends on the theta. That means the angle between the oscillating particles in a wave and what is the axis of the analyzer or the polarizer. Therefore, here the intensity is changed. Now next, the light of the intensity I0 is incident at an angle 45 degrees with the optical axis of a polarizer. So, intensity of the emerging light is, here the light is incident at this way. Light is, intensity is in this direction. Here the polarizer is placed like this way. There is the axis of the polarizer. When the light is incident here, so this angle is 45 degrees. So what is the intensity of the emerging light? From Malus law, we know that I is equal to I0 cos square theta is equal to I0 cos square 45 degrees. Cos 45, 1 upon root 2. Therefore, I0 1 upon root 2 whole square is equal to I0 by 2. That means the 0.5 I0. 0.5 I0. Therefore, answer is 0.5 I0. So that intensity of the emerging light is 0.5 I0. So only we have to use the Malus law, equation of the Malus law. I is equal to I0 cos square theta. Theta is given. The angle between the incident light and axis of the polarizer is 45 degrees. Therefore, I0 cos square 45. I0 cos 45, 1 upon root 2 whole square is equal to I0 by 2. 1 by 2 is equal to 0.5 I0. Now, after that, the next question also asked in 2006, that is in final exam, first two I mock test. what should be wavelength of light to get fifth bright fringes at a point on the screen, where the third bright fringes is obtained using the wavelength of 700 nanometer. 700 nanometer. Therefore, N1 always given the third bright. At this time, the wavelength of the light is 700 nanometer. Now, we want to obtain at the same point the fifth bright fringes. So, what should be the wavelength of the light is required? We know that N1 lambda 1 is equal to N2 lambda 2. We require the lambda 2 is equal to N1 lambda 1 upon N2. Now N1 is given 3 into 700 upon N2 5. 14 fifths are 700. 70, 14 fifths are. So 140 multiplied 3, 420 nanometer. Again, when we are using the wavelength, light of wavelength 700 nanometer, at the time on the screen we obtain the third bright fringe at suppose the x distance. At the same distance, we require the fifth bright fringes. So at that time, what should be the wavelength of light? Therefore, we are using this condition N1 lambda 1 is equal to N2 lambda 2 because the both are bright fringes. Therefore, path difference at their point is same. Right? Therefore, d sin theta is equal to N lambda. Okay. Therefore, N1 lambda 1 is equal to N2 lambda 2. So, lambda 2 is equal to N1 lambda 1 upon N2. We can find out the wavelength like this manner. Now next is on the base of the theory and also that is depends on electromagnetic waves and combination with this chapter. The polarization of the light proved that light is composed of. Now listen, here the options are given: longitudinal wave, transverse wave, streamline waves, and ray without waves. So here, all the waves, polarization is the process related with the light wave. And also already we know that in chapter electromagnetic waves, light are electromagnetic waves. In light waves, the electric field vector and magnetic field vector are oscillate perpendicular to each other and also perpendicular to the direction of propagation of a wave. Therefore, all the light waves are longitudinal waves. All the light waves are longitudinal waves. Thus, the polarization occurs only in the light wave. Therefore, that proves that the waves or the light is composed of longitudinal waves. Clear this? So here there is depends on our knowledge. Not directly given the answer of this question in your text. Now next, limit of resolving for an optical instrument arises due to the interference, polarization phenomena, diffraction and refraction. Already we know that the resolving power of the optical instrument. Resolving power, that means the ability of this optical instrument to see the image of too far and very close object. The image becomes the clear. So here the phenomena of diffraction take place, not interference, not polarization, not diffraction. Therefore, limit of resolving for an optical instrument arises due to the diffraction phenomena. Diffraction phenomena. And also we discussed about the Rayleigh's criterion, about the resolving power. Now next is the ray of light that is asked in 2008 in which said, ray of light moving in the water incident on a glass plate, the reflected light becomes completely polarized. When the incident is 51 degree, so the refractive index of the glass will be. Now for water, the refractive index is given 1.3 and 1051 degrees is equal to 1.235. So we know that the effective index of a glass with respect to water, or the Ng upon Nw, is equal to 1051. That is the Brewster's law. N is equal to 10 theta p. Theta p is the angle when the reflected ray becomes the perfectly or the completely plane polarized. At that time, the effective index N is equal to 10 theta p. Here, angle is given 51 degree, and here effective index of a glass is placed in water medium, therefore Nc upon Nw. 1051 is already given, so we can write, we require the effective index of a glass plate is equal to Nw 1051. Nw is given 1.3, and that is the 1.235. That means the 1.605 is the effective index of a glass plate. Again, from Brewster's law, the angle for which the reflected air becomes the perfectly plane polarized, this angle is theta. Therefore, 10 theta p is equal to effective index of a material. Here, the glass plate is given that is placed in a water because the ray of light traveling in water medium. Therefore, effective index of a glass with respect to water is equal to 10 theta p over the 1051. We require the Mg, effective index of glass, is equal to effective index of water into 1051. All values are given. Nw 1.3 and theta is equal to 51, and value of the 1051 is 1.235, therefore 1.605. Now next question, the diameter of a telescope lens is 0.61 meter. Diameter is given the 0.61 meter. The wavelength of a light is 5000 angstrom. Therefore, lambda is equal to 5000 angstrom, convert into meter, so 5 to 10 is to minus 7. Then resolving power of a telescope. So we know that resolving power of a telescope is equal to D upon 1.227. D is the diameter of objective and lambda is the wavelength of light used, therefore 0.61 upon 1.22 into 5 to 10 is 2 minus 7. Right? So only 10 is to 6 is the resolving power of a telescope. Is 10 is to 6. Here the diameter of objective 0.61 meter and wavelength of a light used in telescope is given 5000 angstrom. We require resolving power of a telescope, therefore RP of telescope is equal to capital D upon 1.22 lambda. Only we need to substitute the value. Diameter is 0.61, wavelength is 5 into 10 is to minus 7 into 1.22, therefore 10 is to 6 is the resolving power of a telescope. Now next question is asked in 2009. In Young's experiment, the distance between two slits is given 0.28 millimeter and distance between the slit and scale is 1.4 meter. If the distance between central band twins and third band twins is 0.9 centimeter, so what should be the wavelength of light used? For that purpose, here keep in mind that what is the situation? Here there is the central band twins. Here first, second and third. Third band twin is obtained here. This distance is x3. x3 is already given, that is the 0.9 centimeter. Right? Therefore, x3 is equal to 0.9 centimeter. Width of the slit is 0.28 millimeter and capital D is given 1.4 meter. We require this. Therefore, condition for maxima for the band width is Now listen, here the condition for in that case. There is the d sine theta and is equal to n. Therefore, sine theta is equal to n lambda upon d, and also we know that there is the xn upon capital D. Xn upon capital D. But here n is equal to third given, and we got the lambda. Lambda is equal to x3d upon 3 capital D. x3 is given 0.3. There is the given the 0.9 centimeter. Now, small d is given 0.28 millimeter, convert into centimeter into 3 upon 140 centimeter. So, is equal to 6,000 angstrom. Again, in diffraction phenomena, here condition for the bad fringes, in bad fringes, d sine theta is equal to n lambda. Actually, here what's upon this way, the figure is formed. So this angle is theta. This angle is theta. Now d sine theta is equal to n lambda. Therefore, sine theta n is equal to n lambda upon 2. But for the figure, sine theta is equal to opposite to the hypotenuse, but theta is very small. Therefore, we consider the tan theta opposite to the adjacent. Therefore, xn upon d. So, compare this two equation, n lambda upon small d is equal to xn upon capital D. We require the lambda. Lambda is equal to xn small d upon n d. Now, we substitute the value of n as 3. Therefore, lambda is equal to x3d upon 3d. And as we substitute the given value, we obtain the wavelength is 6,000 angstrom. Yeah. After that, in 2009, which of the following cannot be polarized? Here, the four different types of the waves are given. First is the ultrasonic wave. Second is the radio wave. Third is ultraviolet waves, and D is the X-ray. Now, radio, ultraviolet, and X-ray are the electromagnetic waves, are the plane polarized. Here, radio, ultraviolet, and X-ray are EM waves, electromagnetic waves. Which are longitudinal. So, these three waves can be polarized, while the ultrasonic waves is not polarized. But ultrasonic waves is non-longitudinal wave. Actually, there is the sinusoidal wave. So, ultrasonic waves is not polarized by the polarization theory. Actually, there is the sound wave, not a light wave, while the radio waves, ultrasonic waves, and X-rays are the light wave. That means the electromagnetic waves, and all the electromagnetic waves are longitudinal waves, and that can be polarized by the phenomena of polarization. While the ultrasonic is the sound wave, and there is the sinusoidal wave, and due to that reason, there is not polarized. Now, next, 100 by phase difference is equal to how much path difference. For that purpose, we must know that what is the relation between the path difference and phase difference. Therefore, path difference is equal to lambda upon 2 pi into phase difference. Lambda upon 2 pi. Here the phase difference is given the 100 pi. So into 100 pi. Pi cancel and 50 is a 100. Therefore 50 lambda is the path difference. So when the condition for the phase difference and path difference for constructive and destructive interference, we are using this concept, the relation between the path difference and phase difference. Path difference is equal to lambda upon 2 pi into phase difference. Phase difference is given, there is the 100 pi. So lambda upon 2 pi into 100 pi, therefore we obtain the 50 lambda is our path difference. Clear? Now after that, the next. What will be angle of the first order maxima obtained by Fraunhofer diffraction by single slit using light of wavelength 500 nanometer? Right. Now listen here, the wavelength of the is given like 500 nanometer. Clear? Therefore 5 into 10 is to minus 7 centimeter. Now here the width of the slit is not given. Width of the slit is required B. So keep in mind that there is the 0.25 millimeter. So convert it into centimeter. Therefore 2.5 into 10 is to minus 2 centimeter. And 5 10 is to minus 7 meter. Now we require what will be the angle of the first order maximum for nth order maximum. For nth order maximum, condition is that d sin theta n is equal to 20 plus 1 lambda by 2. For n is equal to 1, therefore d sin theta 1 is equal to 3 lambda by 2. For small angle, sin theta 1 is approximate theta 1 is equal to 3 lambda upon 2. 3 lambda upon 2. Substitute the value 3 into 5 into 10 is to minus 7 upon 2 into 2.5 into 10 is to minus 4. 10 is to minus, right? Therefore 3 into 10 is to minus 3 again. 3 into 10 is to minus 3 radian is our answer. Again, here Fraunhofer diffraction is given, therefore we are using the condition for nth order maxima. So condition is d sin theta is equal to 20 plus 1 into lambda by 2. Now the lambda given, d given, and order is given the third band. First band. First is substitute the n is equal to 1, therefore d sin theta 1 is equal to 3 lambda by 2. For small angle, sin theta 1 is equal to theta 1, therefore angular value theta 1 is equal to 3 lambda upon 2d. Substitute the value of lambda and d, we obtain the angle of the first order maximum. Now, next is asked in 2011, the width of fringes blank. Yes, the Young's experiment moved from A to water. Now, keep in mind this type of the numerical last we discussed. Here, the width of the fringes in Young's double slit experiment is given the 0.2 degree. Now, we bring this instrument in water and perform the experiment. So, what's happened? The width of the fringes will be, at that time our answer is decreases. Now listen here, why decreases? Because as the medium changes, so what's happened? Wavelength of a light is changed. Wavelength of a light is changed. As we go from here to the denser medium, wavelength of a light is decreases. Wavelength of a light is decreased, therefore the width of the fringes is directly proportional to the wavelength. So there is decreases. Therefore, width of a fringes width of fringes directly proportional to the wavelength. As we move from air, that means the red, to the water, that means denser medium. Wavelength lambda decreases. So, width of fringes also decreases. Because the wavelength decreases, therefore width of the fringes also decreases. Because the width of the fringes 2x bar, or the 2 beta, is directly proportional to the wavelength. And last we also discussed that as the instrument is bent in water medium, so as the medium changes, so wavelength of the light is changed. As we go from here to the denser, wavelength of the light this also decreases. Here we are bringing the Young's experiment from air to the water medium. That means air to the denser, therefore wavelength decreases. As the wavelength decreases, so width of the fringes also decreases. Now, next is, in two tourmaline experiment, the analyzer and polarizer are crossed with each other. At what angle should the analyzer be rotated so that 25% of light passes through the analyzer? So we know that from Malus law. From Malus law, I is equal to I0 cos square theta. Now, emerging light has the intensity is 10 to 5%, therefore I is 0 by 4 cos square theta. Because the light is passing through the analyzer is only 25%, therefore 1/4 of original intensity, therefore I is 0 by 4, therefore 1 by 4 is equal to cos square theta. Therefore cos theta is equal to 1 by 2, therefore theta is equal to 60. There is the angle of analyzer, but we require the how much analyzer is rotating. Therefore, analyzer should be rotated by an angle is equal to 90 minus 60. Why 90 minus 60? Because initially the polarizer and analyzer are crossed each other, that means the perpendicular to each other. Therefore, 30 degrees is the rotation of the analyzer to obtain the 25% intensity of the light passing to the analyzer. Clear? So all these numericals depends on the theory and also the very short numerical factor.